A new Kicad tutorial. This time we are going to design a resistor footprint and assign the resistor footprint. This is Kicad tutorial 1.9c. And now we are at symbol 13 R4 0.033 ohm. And here it is, you can see in a schema R4 0.033 ohm. I've found this resistor at the Element 14 website, SBL 4R033J, current sense resistor 0.033 ohm, SBL series 4 watt metal foil axial leaded. And we can click here to download the datasheet. I've already done that. I'll leave links in the description below for the datasheet as well as for this website. And here is the datasheet of Tyco Electronics SBL series low ohmic current sense resistors. And we see it's a 4 watt resistor, and the one that we are interested in is this R033. But what we're most interested in is the dimensions of the resistor. You see the body length is 18 millimeters. The diameter, although it's square, but the size of 6.4 millimeters each side, the height and width of the resistor. And we see the pitch or width of the width of the pitch is given as 40 millimeters. Now, if we would rewrite that in Kicad format, it will be THT, 3-ohm technology, R for resistor, axial, because the leads extend actually from the body. The length of the body is 18 millimeters. The diameter is 6.4 millimeters. In this case, is actually the width and height of the body. And the pitch is 40 millimeters, and the resistor is horizontally orientated. Now, I've already checked. Kicad does not have a footprint like this, so we'll have to draw our own. So we will have to open the footprint editor, and we will click on the new footprint icon. It is this horizontal IC with the green legs, and we have to enter a name, and I've given mine THT through-hole technology, R axial, L the body length 18 millimeters, D for diameter, which is 6.4 millimeters, and then the pitch, as we've seen in the data sheet, is 40 millimeters, and the resistor is horizontally orientated. There we are, and we click OK, and there we see we already have the name. We have to save this footprint, and we will save it in the Kicad library, Kicad footprints library over there. We'll select it, and we'll click save. And there it is. And we will select the text and move it down a bit, like that. And we will start by adding a pad. And choose pad 1, we put it more or less over here. And we right click and we click cancel. And we select the pad, and we right click and we select properties. And pad number 1 is correct, and we want it at minus 20. And the reason for that is, let me just show you quickly. Remember, the total distance is 40 millimeters between the pads. We want it to be symmetrical to the y-axis, so it's minus 20 in the minus x direction and plus 20 in the plus x direction, and it is of course right on the y-axis, so it is at 0, 0. Okay, and we want it the y-axis, so this is going to be 0. The whole size, we want that to be 1 millimeter, and I see it is already 1 millimeter, and that's that distance, because remember, if you recall, the lead thickness is 0.8 millimeters, so we'll make that all 1 millimeter, be on the safe side, and we'll make this distance 2.5 times the 1 millimeter, and we will click OK. Now for the next pad, we select this pad, we right click, select duplicate, and we'll move this to more or less over here, like that, and we'll right click, and we'll select properties, and we'll make this pad number 2. Now this must be in the plus x direction, so it must be at plus 20, and we will make that 0, 0. That must be 0, 0, 0, 0. And the hole size must be 1 millimeter, and that distance, and the overall diameter must be 2.5 millimeters, and we click OK. And there we have our 2 pads, and we click Save. Okay, so we're now going to start with the fabrication layers, and Kicad says, I'll leave a link in the description below where Kicad discusses the fabrication layer, but it says the fabrication layers are used to display the simplified mechanical outline of components on the PCB or printed circuit board. And f.fab is the front fabrication layer, which is primarily what we're going to work with. The outline uses a line width between 0.1 millimeter and 0.15 millimeters, and it recommends 0.1 millimeters. And it gives here a couple of examples of the fabrication layers for different components. Now we're going to start to draw this line over here, the top line over here, and remember, it is the total width is 18 millimeters, and we're going to be symmetrical around the y-axis, so that point is going to be -9, and half of 6.4, which is going to be -3.2, and that point is going to be +9 -3.2. So we start off by drawing the top horizontal line. So right click, cancel, select the line, right click, properties. We said it's going to be -9. Comma 0. That's going to be -3, comma 2. That's going to be +9. that, and it's going to be minus 3,2, and we're going to the front fabrication layer, so we're going to set that layer to F-fab, and remember the line thickness, the recommended line thickness is 0.1 millimeter, and we click OK, and there's the top horizontal line. Okay, now the bottom horizontal line, we're going to right click, and we're going to click duplicate, and we're going to move it more or less to over here, and we're going to right click it and properties, and it's going to be minus 0.9, and now it's going to be on the positive x side, so it's going to be plus 3,2, and it's going to be plus 9, 0, and it's going to be 3,2 because it's in the plus y part, and the line thickness is already at 0,1, and the layer is F-fab, front fabrication layer, and we're going to click OK. There's the bottom horizontal line. Now the left vertical line, we're going to draw it between the top and bottom horizontal lines, like that. Right click, cancel, select the line, right click, properties, it must be at minus 0, it must be at minus 3,2, and be at minus 0, and the end point must be at 3,2, and the line thickness must be 0, and must be front fabrication, and we click OK. There we are, and we're going to right click, and we're going to select duplicate again. Oh, that's why. Well, there it is. And we can place it more or less where it should be. We're going to right click, we're going to select properties. It must be minus 3,2, and it must be 9,0, and plus 3,2, and line thickness 0,1, F-fab, front fabrication layer. And there we are. Here we have the outline of the component, and now we must just add the leads, and we draw the line, and we right click, and we click cancel, and we select the line, and we right click, click properties, and remember that it is at minus 20 up until minus 9. That's where the lead line is. So it must be at minus 20. That must be on the y-axis, so that must be 0. That must be minus 9, because the width of the body is 18 millimeters. and that must be 0, and it must be 0, 1, and it must be the front fabrication line. We must select that and we click OK. And there we have it. And we select that line again, right click, duplicate, and then we move it to the right like so, and we right click, properties, so it must go from +9 to +20. This must be 0, this must be 0, and it must be 0, 1 millimeter. Fab, front fabrication line, click OK. And there is the outline. And the last thing we have to do is the text. Text we normally put here, and we type in the text box, we type in %R, and it must be front fabrication line, and the rest we can leave it as it is, and we click OK, and there it is. And that's it. Now we've finished the front fabrication layer for the footprint, and we click Save. We are now going to do the silkscreen layer. I'll leave a link in the description of where this discussion is about the silkscreen layer. It says the silkscreen is printed on the external surface of the printed circuit board to aid in component identification orientation. Typically, this layer contains the component revdes to locate components on the board after assembly. And it says that the silkscreen width should normally be 0.12 millimeters. And it gives an example of a resistor, silkscreen. As you can see, here it is. Now we're going to start drawing our silkscreen, and we start off by add a graphic line. We draw a horizontal line like that. Right click, cancel. Select the line. We select properties, and we want the line to start at -9.1 to compensate for the thickness of the fabrication line, and we want to end it at 9.1, and we want the start point at -3.3, once again to compensate for the thickness of 0.1 millimeter of the thickness of the fabrication line, and it must be end at -3.3. Line thickness is 0.12 as discussed, and it is the F front silkscreen layer, and we click OK, and there we have it. And we right click, duplicate, and we put the duplicate line more or less over here, and we right click, properties, once again -9.1 plus 1, 3.3, only difference is positive, plus 3,3, line thickness 0,12, layer F front silk screen, click OK. There it is. Now we're going to draw the left vertical line. And we click, right click, cancel, select the line, properties, and we want it to start at minus 9,1, or rather we want to be at minus 9,1. This is also minus 9,1 on the x-axis. We want to start it at minus 3,3, and we want it to end at plus 3,3. Line thickness 0,12, silk screen, front silk screen layer, click OK. There we are. And we select it again, right click, duplicate, move it to over the right side, right click, properties, is now at plus 9,1, plus 9,1, is now at 9,1, start at minus 3,3, and we want to end at 3,3, and we click OK. And there it is. As you can see, the silk screen is just on the outside of the fabrication layer. We are now going to draw the line on the left side from the body of the resistor towards the pad. There we are, right click, cancel. Let's rather just zoom in here. There we are. Now we want the silk screen one. Right click, properties. You can start at minus 9,1. This is going to be at 0. And we're going to be at minus 18,5. Click OK. And as you can see here, it just stops short of the pad. Now we're going to do the same for the other side. Select this, right click, duplicate, move it to the right side, like that, right click, properties. Only difference is a plus, 18 plus 5, that must be 0, and that must be plus 9,1, and that must be 0, and we click OK, and once again you can zoom in a bit like that, and you can see the silk screen just stops short of the pad, which is exactly as over here in the example of Kicad. Okay, we are now going to draw the courtyard layer of the footprint, and it says here, the component courtyard is defined as the smallest rectangular area that provides a minimum electrical and mechanical clearance around the combined component body and land pattern boundaries. It is allowed to create contoured courtyard area using a polygon instead of a simple rectangle. Then it says here the courtyard uses a line width of 0.05 millimeters. Furthermore, unless otherwise specified, clearance is at 0.25 millimeters. A can capacitor should have a clearance of 0.5 millimeters, crystals clearance of 0.5 millimeters, and connectors should have a clearance of 0.5 millimeters, and BGA devices should have a clearance of 1 millimeter. And then here's a couple of examples. I would just like to show you, I've zoomed this. This is a diagram of Kicad. I've zoomed it a bit. As you can see here, they've drawn the courtyard outline, and there it gives distance as 0.25 millimeters, and that's also 0.25, 0.25. That one's also more or less 0.25. It just gives you an idea of how the courtyard can be drawn around an electronic component. What we further need to discuss is how we are going to make the courtyard, the dimensions of the courtyard. Now we have the pitch, which is 20 millimeters, and then we have the radius of the pads, which is half of 2.5, and that gives us 21.25 millimeters. And we have to add a 0.25 courtyard clearance, and if we add 21.25 millimeters by 0.25 millimeters, it gives us 21.5 millimeters. However, let's make the clearance at 22 millimeters to be on the safe side. That is as far as the width of the courtyard is concerned. As far as the height of the courtyard is concerned, we already have the silkscreen at 3.3 millimeters. If we add a further 0.25 courtyard clearance, then it's 3.3 plus 0.25 millimeters. It gives us 3.55 millimeters. And I've decided to make it 3.6 millimeters. That is just to simplify things. Okay, so here we are. We have to draw the courtyard layer. Start off by drawing the horizontal line like so. Right click, cancel, select the line, properties, and we want that, we said, at 22 minus 22. And we want that at plus 22. And we want that at 3.6 minus 3.6. And that's also minus 3.6. And we want this, we set this as the front courtyard layer, and we want this at remember, I just want to show you quickly, refresh your memory, the courtyard uses a 0.05 millimeter line width. So this must be 0.05, and we click OK. And we right click and we select duplicate and we move the duplicate to more or less over here. And we right click and we select properties, and that must be -22. That must be 3.6 because it's now on the positive side. That must be 22. And that must be 3.6. And the line thickness is 0.05, and it is the front courtyard layer, and we click OK. Now we draw the left vertical line, draw it more or less between the two horizontal lines, like that. And we right click, cancel, select the line, right click, properties, that must be at -22, -3.6, -22, plus 3.6, and that must be 0.05, and it must be the front courtyard layer, and we click OK. And there it is. And we select it, right click, duplicate, move it to the other side, more or less in position over here. Right click, properties, we make that 22 minus 3.6, 22, 3.6, and line thickness is 0.05 millimeters, and the layer is the front courtyard layer, and we click OK. And that's it. There we have our footprint. And our footprint is finished, and we click Save. Okay, so all that needs to be done now is that the footprint that we have made needs to be assigned to symbol 13R4 0.033 ohm, and we click here. We stored it under the Kicad footprints library, and there it is. So all we do is we double click on it, and there it is, and it is assigned to R4, and we can just right click on it and view the footprint, and we can make a couple of measurements from here to here. That's 7.98, must be 18 millimeters. There it is, perfect. The width from here to here is 6.46 millimeters, perfect. And from here, from the one pad to the other pad, must be 40 millimeters, that's 40.07, perfect. And we look at the size of the hole, and from here to here, it's about 1 millimeter, and that's perfect as well. And we click Apply, Save Schematic, and Continue. I think this is enough for now. Next time we will assign a footprint to a switching regulator. I do leave links in the description below. If you have any questions or suggestions, leave them in the comments below. Please click the subscribe button. Thank you for watching and goodbye.